we're going to take notes on pedigrees. This is a picture of a pedigree. As you can note, it has different shapes and they are connected with these lines. So the pedigree's purpose is to show how a genetic trait is inherited throughout several generations. So here is one generation of a family, this would be another family, this is a third family, and then these would be parents of the 3 children in the pedigree. You need to make sure when reading a pedigree that you can tell the difference between a male symbol, which is square, and a female symbol, which is a circle. In a pedigree, the mom and dad are joined with a line, and then their children are connected to them with lines that go underneath to represent that they are the second generation. Often the generations are noted with symbols on the side, and this would be the first child, and this would be the second child, and so forth and so on. If you are coloring in for whoever has a trait, whether it be colorblindness, hemophilia, and if they do not have the trait, you would not color in the shape. If they have the trait, that shape would be color in to say that they have this particular anomaly, meaning not normal. Here's a relationship between a Punnett square and a pedigree, because you will be asked to do that. So in these directions, I tell you that the pedigree is autosomal recessive, and I give you the genotype for each of the parents. So you're going to complete a Punnett square as you normally would, putting the genotypes of one parent along the top and the other parent along the side. And then when you fill in the Punnett square, you'll find out the genotypes that represent all of the offspring possibilities. Now we're going to take this information and fill it in on the Punnett square, on the pedigree to the right. So since the mom and dad are not denoted, we're going to put just randomly choose that the dad is going to have the heterozygous and the mom will be homozygous recessive. And underneath the shapes, we write in their genotypes. Now I color-coded the children in the box to show you that there are 4 children, and notice in the pedigree there are 4 shapes, 2 squares and 2 circles, to represent a 50-50% chance of having a boy or a girl. So we're going to take the first genotype and we're going to write it in randomly just underneath any one of these particular children, offspring shapes. And then we're going to go and we take each one of these and write it in under each shape. So you can see I color-coded them just so that you could see the relationship between in the Punnett square and the pedigree. But we could have changed up those orders. And then the last thing we need to do is we need to color in for those that have this particular trait. This trait, because the directions told us over here, remember, is that it's recessive. So this dad would not have a recessive trait, but the mother would. So we would color in the mother shape. This child will not have it. This child would have the recessive trait. The child next to it would not. This child would have a recessive trait, and the one next to it not. So now our pedigree is done, and you can see that this trait is passed down from the mom and dad to 2 of their offspring. Here's an example with an X-linked trait. Following the similar pattern, I've told you that it's X-linked, so we need to write X's and Y's, and I've told you that it was dominant. So here is the mom and this dad's genotype. So on the pedigree, we're going to write in mom and dad's genotypes on the front and the side, just like the prior chapter, and fill in the Punnett square. When that's done, we can then fill in underneath the pedigree the proper genotypes. So the dad, you need to match up the genotypes to male and female shapes. So the dad specifically had a recessive gene, so you would have to give him the lowercase b, and then the mother would be heterozygous as in the directions. Over here in the offspring, here's one offspring. Notice this is a female, so I would randomly under one of these shapes give the female. Next to that, you could see I already filled in what the male is going to be, the other female, and then the other male. So you do have to correspond males to females if it's a sex-linked trait. Now, coming back, recall that it's a dominant trait, and we're going to shade in those that would have the dominant trait. So of the parents, the mom would have this dominant trait, the dad would not. Of the children, one girl would have this dominant trait, and one boy would have the dominant trait. So we color in the pedigree to demonstrate this. When looking at a pedigree, you'll be asked several questions. One of them is to determine if it's autosomal or sex-linked, and the second question would be to determine if it's showing a dominant or recessive. Autosomal, remember, is going to occur equally in males and females, or be a difference of at least one. If it's sex-linked trait, it's going to occur more in one gender, so that means there'd be more males or females that have this particular trait. Remember, when looking at a pedigree, you only want to look at the ones that are colored in, because those are the ones that have this trait, and the questions are pertaining to the particular trait. So you want to count how many colored in males there are and how many colored females there are. If there's more males than females, it's sex-linked, or if there's more females than males, it would be considered sex-linked. To determine dominant, if you remember Mendel, if it skips a generation, then it would be recessive. So what this would look like is you have a person who has a trait, and if you trace it back to its mom and dad, they would not have the trait. If it's dominant, for every person who has the trait, at least one parent is going to have the trait. It could be either mom or dad, or it could be both. So this would be the situation when only one parent has it and the child has it. So that would be clues to tell you if it's dominant and clues to tell you if it's recessive. So let's look at this particular trait here. Is it dominant or recessive? If you look at this family right here, here is a child who has the trait, and notice that the parents do not. So this would kind of be skipping this generation because the parent did not have it, they did. So this would be considered recessive. Is it sex-linked or autosomal? If you notice the colored in, you have one male, colored in, one female, so this is going to be autosomal. Let's look at this one. Dominant or recessive? If you look at every child who has the trait, at least one of his parents has the trait, so this is an example of a dominant trait. Sex-linked or autosomal? Colored in, we have 1, 2, 3, 4, 5 females. And colored in of males, we have 2. So this would say it's sex-linked. There are more of one gender. In this case, more females have this particular trait. Let's look at these examples. I would like you to pause and see if you can answer these 2 questions for each one of these. Hopefully you paused to test yourself. If you did not, you still have some time to do so now. So picture A here is going to be a dominant trait, and it is going to be autosomal. Picture B is going, it's autosomal because it's equally between its males and its females. Picture B, there are 3 boys and 5 girls, so it will be sex-linked, and it would also be dominant. For every child who has it, at least one parent has it as well. Picture C is sex-linked. There are only boys colored in, and it is recessive. And the reason being is here's a boy who has it and his parents do not. Here's a boy who has it and his parents do not. Picture D is autosomal. It's 2 boys and 2 girls, and it is recessive. Here's a family, and here's a family where the child has it and the parents do not. And lastly, picture E is sex-linked. There are 6 girls and only 2 boys, and it is dominant. For every child who has it, at least one parent. Remember, you're only looking at those that are colored in. Let's look at this one and see if we can come up with writing in the genotypes. So the pattern of inheritance here is going to be autosomal. Because it's about equal, there's only one difference, 3 girls and 3 boys. Oh, so it is equal. And it is going to show a recessive pattern, because over here you have a family who the child has it and the parents do not. So that's a sign that it is recessive. So let's write in their genotypes. So let's draw a little key of what we know. It always says fill in what you know. Because I know it's autosomal recessive, anything colored in is going to have 2 lower cases. So underneath each of those, I'm going to write in their genotypes. The only way to get a recessive gene is if you have 2 recessive alleles. So now working backwards, we're going to look at the family over here to see what we can find out about their children, offspring. So we're looking at this family here. So since this dad had 2 more children over here, we know that they each are going to have a lowercase r because the dad only was able to pass on a lowercase r. So their other letter is going to be a capital R. Now looking back to find the mom, because these children has 2 lowercase r's, they had to get one from mom as well as one from dad. So the genotype there is going to be capital R, lowercase r. In the middle family, right here, since mom had 2 lowercase alleles, all of her offspring have to inherit a lowercase allele. Now the dad, we're going to look at his dad. So we know he has at least 1 lowercase letter because he inherited that from dad, so we know his other is going to be a capital letter that he inherited. And so the offspring here could be a combination of capitals or lowercases. They're going to be capitals. They're going to be hybrids. The family over here, because this offspring here had 2 lowercase letters, we know at least a lowercase letter will be in both parents, so the other option is that they have uppercase letters. On their offspring, it's a cross of 2 hybrids, so in this case we don't have enough information. We know there's going to be at least 1 dominant allele. The other one we don't know, so we can write it as a blank. So this one is not quite sure which one it would have. We need a little bit more information. We have one more person to figure out, and this is the grandmother that's up here. So if you look at her daughter over here, who has 2 lowercase letters, we know she's going to have a lowercase letter and thusly have to have an uppercase letter. So this is how you do a pedigree and figuring out their genotypes. It takes a little bit of practice, a lot of erasure, and some trial and error. This has been fantastico. You guys have a good night.